Welcome to C.M.P lab. In this video, we are going to see fraction. Fraction can be defined as part of a whole or some parts of a whole. Okay, whole, W-H-O-L-E, part of a whole or some parts of a whole. Okay, and fraction has the general form A all over B. Okay, any mathematical expression you see in this form, okay, is a fraction where a is the numerator, numerator, and b is the denominator, Okay, if you look on the board here, we have some diagrams. Okay, these diagrams can be written in mathematical form or can be written in fractions. Okay, we use these to illustrate fractions. All right, and we can write this number one diagram, the number one diagram in fraction as 1 all over 2. Okay, this diagram can be written as 1 all over 2. If you look very well, you see this rectangle is divided into two parts. Okay, the first part of it is shaded. Okay, all right, so the total part of it is 2, but one part of it is shaded. Okay, the part shaded is what is 1, and the total part it is divided into is 2. So we can see that the denominator indicates the total numbers of parts. Okay, indicates the total numbers of parts, and the numerator indicates the part shaded. All right, so this is the part shaded, the numerator, which is 1. Okay, and the total number of parts is 2. All right, so we can write for the second one, the total number of parts here is 4. Okay, and the part shaded is 2. All right, so we can write 2 all over 4. That's 2 taken out of 4. All right, okay, all right, so we can also represent this as 3 all over 4. Okay, all right, the total number of parts here is 4. Okay, and the parts shaded is 3. Okay, 1 2 3. All right, so this is 3 all over the total number of parts 4. Okay, the next thing we are going to consider is types of fraction, and the first type of fraction here is proper fraction. Okay, proper fraction is a type of fraction that has its numerator smaller than the denominator. In other words, the denominator of a proper fraction is bigger than or greater than the numerator. Okay, for example, we have here on the board, we have 2 all over 3, 5 all over 7, 8 all over 11, etc. You can see the numerators of all of these fractions listed are smaller than the denominators. All right, so the second type of fraction is the improper fraction. The improper fraction has its numerator greater than the denominator. Example: 10 all over 3, 11 all over 2, 17 all over 7. Okay, and the next type of fraction is the mixed fraction. Now, this kind of fraction has a whole number and an improper fraction. Okay, it has a whole number and an improper fraction. For example, we have here 10. Okay, this is a whole number. We have here 10 4 all over 3. Okay, this is called 10 whole number 4 all over 3. All right, the 4 all over 3 is the improper fraction, and the 10 here is the whole number. And the second one, 7 whole number 3 all over 2. Okay, the 7 here is the whole number, and the fraction, the 2 all over 3, is an improper fraction, which you can see the numerator is greater than the denominator. Okay, and the same follows for the last one. All right, so mixed fraction has a whole number and an improper fraction. Okay, we are going to consider the next thing, which is addition of fractions. Now, to add or subtract fractions is that the criterion is that the denominators of the fractions must be the same. If the denominators are not the same, we take it to we make the denominators the same. How do we do that? Is by using the denominator of the second fraction to multiply by the first fraction, and using the denominator of the first fraction to multiply by the second fraction. Okay, or we use the LCM method in solving that. Okay, which I'm going to show as we solve these examples. All right, so we have a question here: simplify the following: I 2 all over 3 plus 1 all over 3. All right. Okay, in this case, since the denominators of the fractions are the same, we take it to a single denominator and add the fractions and add the numerators. Okay, take it to single denominator and we add the numerators. Okay, 2 plus 1 is 3 all over the denominator 3. We cancel itself 1, cancel 3, 1, and 1 divided by 1 is 1. Okay, we'll go to the next question, the II question. Okay, we have 5 all over 2 plus 8 all over 4. Now we said that the criterion to add or subtract fractions is that the denominators of the fractions must be the same. In this case, the denominators are not the same, so we have to make them the same. Okay, so we use the denominator of the second fraction to multiply by the first fraction. Okay, that is, we have 5 times 4 all over 2 times 4. Yeah, multiply and multiply, and we use here multiply multiply, plus 8 times 2 all over 4 times 2. Okay, and we have that 5 times 4 is equal to 20, and 2 times 4 is 8, plus 8 times 2 is 16. Okay, and 4 times 2 is 8. All right, so now we can see that the denominators are now the same, so we'll take it to a single denominator and add the numerators. Okay, so we have 20 plus 16 all over 8. Because the denominators are now equal, are the same, we take it to a single denominator and we add the fractions. So we have that 20 plus 16 is equal to 36 all over 8. Okay, and we divide them by common factors. Okay, now 2 goes into 8 is 4 times. All right, and 2 goes into 36 18 times. Okay, and 2 goes into 4 2 times, and 2 will go into 18 9 times. So 9 and 2 has no common factor, so this is equal to 9 all over 2. The fraction is in its simplest form. All right, we are going to consider still the II question using LCM method. Okay, now in the LCM method, we are going to look for the smallest number which 2 and 4 can divide. Okay, yeah, we are going to look for the smallest number, the lowest number, lowest common multiple. That's what the LCM means. So we are going to look for the smallest number 2 and 4 can divide. Okay, so to do that, the smallest number, to get the smallest number that the denominators can divide, is by multiplying the denominators with each other. Okay, now we have to get that the LCM. We say 2 times 4. Okay, the 2 times 4 is 8. So the smallest number will be that the denominators can divide will be 8. Okay, now we have 8 here, and we say 2 goes into 8 how many times? 2 goes into 8 is 4 times. All right, then first the denominator of the first fraction divides this, okay, 4 times. So we have 4 times 5, which is 20. Okay, now our plus sign here, 4 will go into 8 2 times. Okay, and 2 times 8 is 16. All right, so now we have that 20 plus 16 all over 8, and 20 plus 16 is 36 all over 8. Okay, so we divide by common factors. 2 goes into 8 4 times, goes into 36 18 times, goes into 4 2 goes into 4 2 times, goes into 18 9 times. So we have that that is equal to 9 all over 2. Okay, this is using LCM method in solving this. All right, okay, we are going to go to the next question, which is the II question, the third question. All right, and now if you look here, you see that these are mixed fractions, and we cannot directly add these fractions like this, okay, as mixed fractions. We can't directly add them as mixed fractions. Okay, so what we are going to do is, first we must, whenever it appears like this, what you do first is you convert it from mixed fraction to improper fraction, okay, before you're able to add or subtract or multiply or divide. Okay, when the fractions are in mixed fractions, you convert them first to improper fraction. All right, so we have 5 times 4 is 20 plus 1 is 21. So we have 21 all over 4. 4 times 2 times 4, okay, the whole number times the denominator plus 1. Okay, 2 times 4, that's 8, plus 1, that's 9. So we have 9 all over 4. All right, okay, there's no point using the denominator multiplying the fractions by their opposite denominators. There's no need, because the denominators are equal. So you just directly take it to a single denominator and add the numerators. So we have that 21 plus 9, we have 21 plus 9 all over 4, and 21 plus 9 is equal to 30 all over 4. Okay, so that 2 will go into, dividing by them by their common factors, 2 goes into 4 2 times, goes into 30 15 times. Okay, 15 and 2 has no common factor, so the fraction is in its simplest form. So we have 15 all over 2. All right, thank you for watching C.M.P Lab. Please share, like and subscribe to get notified each time we bring new videos. Please don't fail to ask your question in the comment box. Thank you.